In this video, we're going to look at ionic bonding. So let's look back to the periodic table and the trends on the periodic table. So you might recall that metals, they tend to lose electrons, and this is because they have low ionization energy. And so because they have low ionization energy, it does not take very much energy to remove an electron from them, and they tend to form cations, positively charged ions. So, on the other hand, nonmetals, they tend to have very high ionization energy. You could also say that they have high electronegativity, and what that means is negativity. What that means is that nonmetals, they will pull electrons towards them quite well. And so if they're good at pulling electrons towards them, they're good at becoming negative ions, also known as anions. So nonmetals on the right of the periodic table, they'll gain electrons. Metals on the left, they will lose electrons. So when elements come together and form compounds, they can form ionic compounds if we have a metal and a nonmetal transferring electrons. So in the case of lithium, lithium is a group 1 metal, and because it's group 1, it has 1 valence electron, which I'm going to show right here, like that. And fluorine is a group 7 nonmetal, so it will have 7 valence electrons, 7 electrons in its outermost shell. Now, lithium will want to lose this 1 electron, and so it will transfer that electron to fluorine, which actually just wants to gain 1 electron itself. And so when that transfer occurs, we get a lithium cation. Lithium is positive because it has lost a negatively charged electron, and fluorine becomes the -1 fluoride anion. Notice it has an extra electron now. I can put that in brackets and the negative outside it just to clarify that that negative charge is in one of the electrons here. The formula of the compound formed between lithium and fluorine, that is LiF. But let's make a comparison here. If lithium is forming a compound with oxygen, well, lithium has 1 valence electron. Oxygen, though, is 1 to the left of fluorine, so it only has 6 valence electrons, 6 in its outermost shell. Now, lithium still wants to give an electron to oxygen, but that's all it can give, and oxygen still needs another electron, and that is why a second lithium atom with a valence electron will transfer that electron to the same oxygen, and what we get is Li positive, another Li positive, and an O that now has its full outermost shell, having gained 2 electrons, which makes it negatively 2 charged. And the formula for this compound would be Li2O, which may seem a little bit familiar. It's kind of like H2O. Note that hydrogen and lithium are in the same group, so they should form similar compounds, H2O, Li2O. Sodium would form Na2O as well, for example. Now let's look at the periodic table, because this can help us make predictions about charges and compounds that are going to form from different elements. So if we look at group 1, every single group 1 element is going to be able to lose its valence electron and become positively 1 charged. And that's because if you remove an electron from lithium, for example, it has a full outermost shell. It has a full electron configuration of helium. Sodium, when it loses its valence electron, it has the electron configuration of neon, etc., etc. And really all elements, if they're forming ions, they want to have the electron configuration of one of these noble gases, one of these group 8 elements. So you can say that all the group 1s are going to go positive 1, all the group 2s will go positive 2, and the group 3s, for the most part, they're going to become positive 3. Group 4, it's really in the middle, and they're probably not going to form ionic compounds. They'll probably form covalent compounds, so you don't really see charges here. But the group 5s, they'll be negative 3, group 6s will be negative 2, group 7s will be negative 1. Notice it really is a question of how far away are they from the group 8. Group 7s are 1 away, so they gain 1 electron, that's why they become negative 1. Group 2s, group 6s, they have to become negative 2 because they need to gain 2 electrons. You might notice that there are some missing elements, and that's because they're going to be metals, and metals typically lose electrons, so you probably wouldn't see bismuth becoming negative 3, actually. That's a bit complicated, and you're not going to see it in this class, what happens over here. I'll also point out that with the transition metals, typically there are more than one possible state. For example, titanium can be +2 or +4. Don't worry about that for now. What you should know, though, is that zinc, silver, and cadmium only can have these 3 charges. So zinc and cadmium are going to be positive 2 if they form compounds, and that's the only option. Silver will only ever be positive 1 in a compound. But everything else, there are different possibilities. So let's move forward. What is the formula for the compound formed from calcium and oxygen? We can actually use the periodic table to help ourselves here, because I know that calcium is going to form a positive 2 ion. It's group 2, it forms a positive 2 ion, and I know that oxygen is in group 6, it will form a negative 2 ion, so I know Ca plus 2, O negative 2, well, I just need 1 calcium and 1 oxygen, because the positive 2 and the negative 2 cancel out, and we end up with a neutral compound. Now, I'm just going to get rid of that there. That is the actual formula of the compound. So if you're ever showing your work, I suppose you could have the positive 2 and the negative 2, but what I want you to show as your answer is that the formula is CaO. Let's take a look at aluminum and chlorine. Aluminum is group 3. It forms a positive 3 ion, Al plus 3, and then Cl is going to be, it's a group 7 element, so it'll go negative 1. So that negative 1, let's see, how many negative 1s do I need with a positive 3? I need 3 negative 1s. So I say AlCl3. And something that you might notice is, if I take that 1 and move it down here, it's not changing anything, but if I take that 3 and move it down here, hey, look, I've got AlCl3, and that actually is the formula of the compound. So this would be our answer, AlCl3. Finally, we have magnesium and nitrogen. Magnesium is going to be positive 2, nitrogen is going to be negative 3, and so I can say Mg with a positive 2, N with a negative 3. I can take these and crisscross them, and I will get Mg3N2 as my compound. And this trick, it's nice to have. I do caution you, had you used that over here, you would have got Ca2O2, but because they're divisible by 2, you should really go back to CaO. Ultimately, all we're trying to do here is get the positive charges and negative charges to cancel out. When I see this, what I really think is Mg positive 2, Mg positive 2, Mg positive 2, and that's a combined 2, 4, 6 positive charge. My N is negative 3 and negative 3. That is negative 6 total, and so positive 6, negative 6, they cancel out when my formula is Mg3N2. So that's how we can figure out the formulas of ionic compounds. Hope you've enjoyed this. Hope you find it useful.